Find the derivative of y equals 5x squared minus 4x plus 3 all over x squared, A, by using the quotient rule, B, by taking the quotient first, and differentiating the result. For part A, y is the quotient, the division of two different expressions. 5x squared minus 4x plus 3 divided by or over x squared. The derivative, y prime, or dy dx, will require the quotient rule. The quotient rule is the derivative of the numerator. There's three terms in the numerator. Derivative of the first term, bring the 2 down, it's power rule, times 5, 10. X to the 2 minus 1, x to the first. The second term, negative 4x, constant times x, the derivative will be the constant, negative 4. The third term, positive 3, a constant with no x, the derivative will be a 0. The derivative of the numerator times the denominator left alone, x squared, minus the numerator left alone, 5x squared minus 4x plus 3, times the derivative of the denominator. It's a power rule, bring the 2 down, subtract 1 from the power, that'll be x to the first. All over the denominator squared. So y prime, or dy dx, will be, in the numerator, I'm going to distribute the x squared into the 10x minus 4. That will give us 10x times x squared, 10x cubed, minus 4 times x squared, minus 4x squared. I'm now going to distribute the negative and the 2x into the 5x squared minus 4x plus 3. Negative 2x times a 5x squared is negative 10x cubed. Negative 2x times a negative 4x will be a positive 8x squared. And a negative 2x times a positive 3 will be a negative 6x. All of this is over x squared squared, x to the 2 raised to the 2. In this case, you multiply those exponents 2 times 2, and that'll be x to the 4. Back in the numerator, we can combine like terms. We have 10x cubed and a negative 10x cubed. Those actually cancel. We have a negative 4x squared and a positive 8x squared. 8 minus 4 is a 4x squared. And then we have a negative 6x, and all of this is over x to the 4th. We do have a common factor of x from the numerator, as well as a 2. But the 2 will not be able to cancel with anything in the denominator, so I'm not going to factor a 2 out, but I'm going to factor the x out because it can cancel with one of the x's in the denominator. So let's factor an x out. X times 4x minus 6 over x to the 4th, and we can cancel out this x, which is multiplying the rest of the numerator, with one of the x's down here, leaving us an x cubed. And we can write it as 4x minus 6 over x cubed. For part B, y, which is 5x squared minus 4x plus 3 over x squared, has a single term in the denominator. So each term in the numerator can be separated over that single term in the denominator, common denominator. For the first term, the x squareds can cancel. We will cancel those out. And that'll leave us with a 5. For the second term, one of the x's from the numerator and the denominator will cancel. That'll leave us a minus 4 over x. And the last term, there's no x's to cancel, so it'll remain 3 over x squared. we can rewrite the second and third terms by moving the x to the numerator as a negative exponent. So 5 minus 4x to the negative 1, move it to the numerator as a negative exponent, plus 3x to the negative 2, again move it to the numerator as a negative exponent. Each of these terms are now combined by addition or subtraction, so we can take the derivative of each of them separately and combine the results by addition or subtraction accordingly. Our derivative, y prime, which can also be written as dy dx, will equal, the first term is a constant, derivative of a constant is 0. The second term will be a power rule. We'll bring the power down, negative 1, multiplied by the negative 4, already down there, and subtract 1 from the exponent. Minus 1 more is minus 2. Plus 3 will bring the power down, negative 2, and then x raised to the, we'll subtract 1 from the exponent. Minus 2 minus 1 more is a minus 3. Negative 4 times negative 1 is positive 4, x to the negative 2. And then 3 times a negative 2 is a negative 6, x to the negative 3. The next step is to rewrite these to have positive exponents by moving those negative exponents to the denominator. The 4 doesn't move. The x to the negative 2 will be x to the positive 2 in the denominator. The negative 6 doesn't move. The x to the negative 3 will be x to the positive 3 in the denominator. The last thing we can do to make it look like part A is to get a common denominator. We can multiply this first term by x over x to produce the common denominator of x cubed. And that will give us 4x over x cubed minus 6 over x cubed. Combining these together, 4x minus 6 over x cubed, which matches exactly what we had produced in part A for the derivative.